So 4A was all about converting stuff to like monthly expenses. 4B was where we started introducing simple and compound interest. So knowing the simple interest, knowing the compound interest, how to find those things. And again, like I'm not expecting you to like memorize these formulas, right? And let me swap my camera. Like this is what I will probably have. It'll probably be just copy paste this thing. So starting with what compound interest formula. So I think simple interest I even left off of here. So I haven't put this up yet, so don't like freak out. Like I know this is an old quiz. And we take the principal and we add the principal, the rate. I don't know if the book even gives you this, right? Times the time. Sometimes they tell you 1 plus y, I think. So what I think when I went and did simple interest in the book, I just multiplied the principal by the rate and then multiplied it by the number of years. And then I went back and added it to the principal. So you figure out what your interest is. It's simple interest, so it should be, wait for the pun, simple to find, hopefully. So simple interest should be simple to find, hopefully. And then we go back at it to the principal. So I don't even think I gave you a formula for this. I don't even think I did a formula in the notes. I think I just did it. So if that's something that you need to know or something that you're having difficulty with, this might be another thing. This might be something you have to memorize. I don't know. So if you have to memorize how to find simple interest, then maybe do that. But like for the most part, I'm going to give you like these formulas. You will get these formulas. You will get the compound interest. So this is found when we compound once per year. If we compound more than once per year, we have to throw that n variable in there. So you do have to know like what these variables mean. N is the number of compounding periods. Y is the number of years. My APR is my annual percentage rate. My P is my principal. This lowercase e, that's Euler's constant, that little lowercase e. You have to know that these things are exponents. And then the savings plan formula. So I believe these three we went over in 4B. 4C, I believe we went over these two things and these two things. There was a savings plan formula. So this is basically the same formula, just written in a different way. And I kind of went over that in the notes. But if we're dividing by a fraction, it's like we flip it and multiply. And I know this one has the A on the top. I'm not sure in the notes if it has it like that or not. It might be out in front. I think in the notes I went A times PR over N. I think the A was out in front of this fraction. I could be wrong. But either way, it's the same formula. Whether we put the A out in front or we put it on top, it is doing the same thing. All right, because if we put it out in front, like as a whole thing, we could always think about it as being like maybe over 1 or something. It's going to get multiplied to the top. This is pretty straightforward. I think A minus B over P, we're doing the relative difference to find our total return. So when we do the total return, we don't even care about how many years we have it in there. We just care about like total, how much did we make? What is the relative difference? The annual return, this is where we start doing some weird things like fractional exponents. So you want to make sure you're putting in fractional exponents correctly. Make sure your device or whatever you're using to calculate these things will be able to do something. Or figure these things out in pieces, right? If you have to, and then plug them into your device. And then the last thing, there's really one other like really complicated formula we're gonna use, and that's not coming up until 4D. So 4D, we will learn about loan repayments. 4D is all about loan repayments, and 4E is all about taxes. So in case you wanted to learn all about taxes and figuring out taxes, and that will be that last 4E. We'll talk a little bit about the graduated tax system and how to figure out things in tax brackets. Okay, so any questions about any of this that I went over? What you're kind of expected to know for the next test? So we have this section, we have 4D and 4E, and then we are done with chapter 4. And next week we will be taking the test over it, right? We'll be studying for the test and taking the test next week, I believe, is what the syllabus says. All right. Are y'all ready to start this? Hopefully. I gotta like put my phone on silent. It keeps beeping and booping. There we go. That's disturbing. Okay, so I got the problems here. 23, your goal is to create a college fund for your child. Suppose that you find a fund that offers APR 5%. How much should you deposit monthly to accumulate 170K in 15 years? And so hopefully you realize you're trying to do a, how do you know the difference? That's a good question. How do you know the difference between like doing the compound interest and doing a savings plan? What's like the defining difference between like this thing versus this thing? What's the main difference between like these formulas and this formula? There's like one variable we're introducing here, right?
Isn't it the payment?
Exactly, right? So this is like I put money in there and I don't do anything else to that account, right? So I forget the guy's name again. God, Rip Van Winkle, right? I'm just like, I'm falling asleep on this money, right? I'm not doing anything to this money. I'm not touching it. I'm dead asleep. I'm not doing anything to it. This, I'm making payments. I'm making regular payments on this thing, right? Regular payments versus goofy payments. So regular payments means they're all the same amount is what regular means, right? Okay. So what's the indicator here in this problem? Like what formula should we use? There's like a word there. How much should you deposit monthly? That's, they don't say the word, but that's another way to say what? You're making a payment, right? If you're depositing monthly regularly, you're making payments. So they're telling you you're making payments. They want to know what payment you're going to make. So then if I'm
170,000.
If I'm looking here, which of these formulas do I want to use if I want to find payment? The left or right?
Okay, I use the left one. So, no.
They are, yeah.
The left, yeah, the left one I did. I think that's what, yeah, that's what I did. The left one.
So then you're gonna plug in for A, right? You're gonna plug in like 170, and then you have to back solve to find payment if you do that. You can do it that way.
Okay, so I did it 05 divided by 12, and then I did it plus 1, and then I got stuck because after I got the answer, which is 1.00416, I got stuck. I didn't know my next move.
Okay, so it is easier to do it this way, right?
Okay.
If we want to find payment, this one is the easier one to plug into. It is solved for payment.
Okay.
You will get similar numbers, right? They will just be flipped, and then you'll have to flip them and multiply or something.
Hey, Professor, I've got a question.
Yeah.
You see the one on the left. I went to the section in the book where they talked about it. And so if you use that formula on the left, is that the one, like, are you supposed to multiply and divide on each side and start canceling out everything?
Are you talking about this one versus this one?
Yeah, no, the first one.
Yeah.
So this one is the same as this one. They're just solving it for a different variable. So I'm a little confused on the question. Like, are we supposed to what?
Well, I just looked at the section in the book to solve this problem. And it said to multiply and divide on the same side, and you like start canceling out all this stuff, like terms.
Yeah,
I think he needs to convert that to convert how you solve it.
to convert this one to this one. Is that what you're saying?
Yeah.
They might be doing that. So in order to do this, what essentially we're doing is we're multiplying by the reciprocal of this thing here, right? If we multiply by the reciprocal, like APR over N, it's going to get really messy, and I'm trying not to write. APR over N over that big junk one plus APR over N. To the NY, right, minus 1.
Yeah.
Multiply by
Okay,
this
yeah.
thing.
Yeah,
We
that's the
multiply-
way.
If we multiply by this thing on this side and on this side, we end up getting this formula.
Okay, so I'm confused now because all I know is that the
These two,
parentheses, and then you go to 12 times 15, I believe, on top of that answer, minus 1. I'm not really sure about what I'm doing here, so I'm trying to figure this out.
okay.
Is it 12 times 15, or how does this work?
So these two are the same formula. It should not matter which one you use, but this one is a little bit easier to use because it's set up straight to solve your payment. So if I want to do the one on the right, it should be a little bit easier to solve it. So if I'm doing this, I'm doing my APR over N. My APR is the 0.05
Over 12.
over 12, which is monthly.
Right. I did
Now
that.
I'm doing
Plus
1 plus that.
Yeah, which is 1.00416.
Okay, it's starting to look like that. I see what you're doing.
And
Yeah.
I'm doing this to the NY, which is 12 times how many years? What do they give us in the problem?
15
12
years.
times
15
15.
years. And then I have to subtract 1.
Okay, so do I do the first parentheses on the 1 plus 0.05 divided by 12, and then I go 12 times 15?
Okay, so this, I missed one amount. Got to do the accumulated amount. They want 170,000.
170,000, right.
I should probably fill that in since I'm filling in numbers.
It's already in. I just wanted, yeah,
Okay,
go ahead.
so
Go ahead,
point-
Professor.
0.05 over 12 is 0.00467, somewhere in that ballpark.
1 point. If you add the 1.
And then here it's 1.004167, right? If we add the
Right.
1 to it.
Okay, that's where I'm at.
And then 12 times 15. Yeah, you're on the right in the right path. That's what I'm trying to say. In the right
So
ballpark.
it's
here.
12. Okay, so then you do the 12 times 15, right?
Yep, that's what you said. Yep.
Okay, okay. So
Do the
then
parentheses first. And so now we got this 1.004167.
12 times 15 equals.
And I'm probably going to do things without rounding them. So if you're getting like a little bit off from like whatever I'm doing, because usually what I do is I recall the answer in my calculator. I've done these enough. I don't know. You can do that thing where you recall your answer and you don't have to round things. It's a little bit prettier. But I'm not expecting you to be exact on these things. Like you're doing these things by hand and you're doing them with a calculator. They don't have to be exact.
Okay, that's 180. Okay, so then that's 1.00416 divided by 180. Is that correct?
We're getting like 2.113. So 1.004167, and we have to raise that to the 180 power.
So that's times 180.
No, that is raised to the power. That is an exponent.
So it's the. So that's where I'm confused at, the 180 part. So is it 180 minus, is it 180 divided by?
No, this is an exponent. So this is the base, this is the exponent.
Okay, so.
So you got to do 1.004167, and you have to raise that to the 180 power. So I don't know how this looks on your calculator. It's a little bit different with each. how you do exponents, but it should be giving you something around 2.1138, somewhere in that ballpark. So it might be like a lowercase, like a to the b. Sometimes they do that, like an a to the b or something like that on your calculator. They're all a little bit different with how they do exponents. So without looking at your calculator and trying to do it myself, it's a bit hard for me to tell you. Might be one of those things you got to look up how to do exponents.
So you got, what was the answer?
It should be around 2.1138.
Okay, hold on, let's see here. Oh, shoot. 0.004.
But this means we're multiplying like 1.004167. That means we have this multiplied out like 180 different times, right? It's kind of ridiculous. Definitely don't want to do that by hand, but okay, so we got what, 0.05 over 12, we got 180, subtract 1. 0.004167. And now this looks like 1.1137, somewhere in that ballpark when I subtract 1 from it. Now I take 0.5 over 12 to divide that thing. Ooh, I missed my number off of here. My 170,000, I dropped it off of here somewhere along the line. I was like, that seems really low. Okay, and I should be multiplying this by 0.374, somewhere around there is what I'm getting for this number. I think the exact solution I should get is 636.02. Let's see. Are y'all getting something close, hopefully? It might be a little different if you round it.
So is that 17000 divided by 0.00374?
Where, what'd you say?
170,000 divided by 0.00374?
This is multiplication.
Okay,
So this is like a whole number out in front. If we wanted to, we could like put that over 1 or something. But what this indicates is that these two things are being multiplied.
Okay.
I think with rounding, I'm getting like 635.99 or something like that, right?
635.8.
Yeah, that's it. You round it to that many things. So 636, 635.8. You're talking about what? 20 cents or something there? 22 cents? It's pretty close. If you're 20 cents off on $600, right? I don't think it's too big of a deal. Are there any questions about this one? Are you getting those exponents yet?
Yeah, I'm stuck on the exponent. How do you calculate this exponent? Does the exponent of 1.004167, and you have the 180 there.
What's
Is
your,
it-
you have your calculator with you?
Yeah.
All right. Can you like hold up to the screen? Maybe I can see it.
Okay.
Maybe I can help you. How do I get to your? I want to view it. Speaker view.
Oh my God, can you see it?
Are you using your phone?
Yeah, it's a calculator on my phone.
Oh, well, you can't use that for the test, man.
No, I know. I don't use it for that.
Using your phone calculator, man.
Yeah.
It should be on your phone. I think it's on my phone. Let me double check. That's not gonna do the
Where's my calculator? Let me find this thing.
test.
Jesus.
It is that thing that looks like X to the Y. If that's what it looks like in yours, I don't know. It might be different.
X to the Y.
Yeah, is that what it says? Something along those lines.
Wait, hold on. Let me back it up.
On my calculator, it says X to the Y. I can't see that. It's like shining horribly.
Yeah. That's all right. Let me find my calculator. Yeah, I gotta find that thing.
All right. All right. Yeah, so definitely find something that can do exponents. I don't know how to. I'm not sure what else to say
All right,
besides
okay,
you definitely
sorry about
gonna need.
that. Sorry about that.
You're definitely gonna need to do exponents with these problems. Like almost all these formulas have some kind of form of exponent, right? This
All right,
one's
let
got an
me see
exponent.
here.
This one's got an exponent. That guy's got an exponent.
Okay, so we went 7. I mean, excuse me. 1. Yeah, that's it. 1 point. Here. 1.
Okay, so I think the next thing says what? At age 20, when you graduate, you start saving for retirement. If your investment plan pays an APR of 4.5%, and you want to have 2.5 million when you retire and 4.5 years, how much should you deposit monthly?
Oh, okay. You know, I did it with the other calculator and it came out right on the number 00476. So I guess I'm gonna keep using this. That's what I'm doing. All right, thank you, Professor.
So we're done. Hopefully you notice, and I'm not trying to make these like super complicated, right? But you got to know which formula you're going to for this thing, right? So what's the giveaway? Like, and I kind of said it already. Like these things have a payment, right? They're telling me somewhere in here that I'm going to make a payment. At age 20, when you graduate, start saving for retirement. Investment plan plays that much. You're gonna have this much. How much should you deposit monthly? So we want to know how much our payment should be. Our monthly deposit is another way of saying payment. And so we're looking here. If we want to know an accumulated amount after making so many payments, that's the one we would use this one for, right? If we have an accumulated amount and we want to know the payments, we got to use this one. So we're back to using, let me admit this guy. We're back to using this equation again. So payment equals APR over N. One plus that. I have to subtract one. So horribly written, but I got my thing on there. That is my formula. So now I'm looking at my problem and I'm trying to pick things out of the problem that match what is being said in this formula. So at age 20, blah, blah, blah. We're starting retirement. Investment plan of APR of 4.5%. So if my APR is 4.5%, first thing I got to do is convert that to a decimal. I know my N is when I'm making my payments. So in general, in this section, I think for most of the time, I think N is going to be monthly, right? Which is, are we awake? What's my N value here? if it's monthly.
12.
Yeah, okay. I was making sure y'all still there. 1 plus 0.045, thank you. Over 12 to the n, which is 12. And I've got to multiply this by the number of years. What are they saying in the problem? 45 years is how long they're giving us to retire. I have to subtract 1. And the other information I got to put in here is the accumulated amount. So they want what, 2.5 million? So 2,500,000. And this is what my payment should be. Okay. Well, this is even. I ain't gonna be able to check it. So guess you'll just have to have a little faith. 0.045 over 12. So a lot of these things we can simplify. 0, 0, 0. So there's the 2.5 million. I'm multiplying that by some big crazy fraction. 0.045 over 12. So I can do these a little piece at a time. 0.00375 is what that's giving me. All right, so what am I getting on the bottom here? I'm hoping like once you do this thing is like super quick. If this is 0.00375, what's going in the parentheses here? Oh man. It should be what, 1.00375, and what is that?
That's correct. That means plus the 1. It was 0.0375, but you had to add 1.
It should be 0.00375 is what this thing is, and then I add 1 to it. It should be the same thing as this one, just with 1 added, right? If you do this thing is just 1 added to it. And then this is to what power now?
540th.
Yep, so I got to raise this to the 540th power and then subtract 1. So another thing about like order of operations is we have to do this exponents before we start doing the subtraction. So I think some people get that a little out of order. They're like, it's really easy to subtract 1 now. No, got to raise the exponents. 1.00375, and we raise this to the 540th power. So that's giving me something like 7.547. And then I subtract 1 from it. So I know I'm probably writing out a lot of steps, but like I want to make sure like y'all can follow along. You could probably skip maybe like a step or 2 if I'm being honest. But again, like people always ask, well, how much work do I need to show? It's like, how much do you really want to risk your grade? I don't like, because if you get any of this wrong at any step along the way, and I don't see the step that you got it wrong, it's really hard to grade it and know where you got things wrong, right? And so you end up like not getting good credit. Try to do this right. 0.00375, and I divide it by 6.547. I'm getting an extremely small number, which I'm hopefully kind of expecting because I got to multiply it by what, 2 million? This isn't pretty, but it's giving me something in scientific notation, 5.7274. I guess I could probably write this out as what, a decimal, which would move it over 4 spaces. So there would be like 3 zeros in front of the 5. And if I multiply this by 2.5 million, it should be giving me a payment of what, 1431, and I'm going to round to 2 decimal places, 85. Are we getting somewhere in the ballpark of this? Like, I'm not sure how to say this nicely, but like you absolutely, if you like, you don't want to follow along with this stuff, like you absolutely don't have to, right? But at some point you're going to end up taking a test over this material. So it might be within your interest to like follow along a little bit. Make sure you have a calculator. Make sure you can do these calculations on your calculator. Make sure you're doing your order of operations correctly. Like those are the things you should be doing during this class, like while I'm doing these examples.
Okay, sir. So I keep getting confused with the top part. Keep going up. Right there where it says the 1.00375 over 540.
This
and
is 2. That's an
let me try
exponent.
this again. 1.0.
So we got to do that with exponents.
375. 1.0075. Now is that time? So is that the arrow up on the calculator?
Yeah, and so if you have a little, arrow, that would be the little arrow. God, what do they call it?
540.
It's a little hat. Is little hat symbols that they call it sometimes?
Yeah.
A carrot?
Carrot. That's it. I was trying to think of the word.
So when I do that, I get 7.5474. Is that correct? Yeah, that's okay.
You should get like 7.547. Is that what you said?
Yes. Yeah.
Okay. Yeah, it's just.
So now the 7.547.
Then you subtract 1 from that, and so you should be getting 6.547 on bottom. Is your next step.
Equals, yes, 6.547. Okay. Oh, I finally figured it out.
Then we take this, divide it, and multiply it, right?
All right. So now 7. Okay. Then I'm divide that. That's how I got this number. 57274. Then so is that like time? Do I do the 10 minus 9 or?
That's -4. It should be like this decimal is what my calculator is giving me basically, right?
Okay, hold on.
They're giving me an e to the -4, right? We talked a little bit about that before. But if I have, like my calculator sits out me an e, which literally means like times 10 to the -4. It's in scientific notation is what it's doing. It's like such a small number that it doesn't want to give it to me in ordinary notation is what my calculator is telling me.
It's still going. Jesus. 57274 again.
0.00057274. And if we multiply that by 25, let's see here. It should be 1431. Oh, that hits it on the spot. I don't even have to round it. So even with rounding, that one should hit perfectly when you multiply.
1431.
85.
85.
That's it. You got it.
Jesus. That was crazy. Okay, thank you, Professor. I'm gonna get off the air.
And 27. So with 27 is probably going to be pretty similar. I think they're all kind of together. Suppose you are 30 years old and you would like to retire at age 60, having accumulated a retirement fund from which you could draw an income of 100,000 per year forever. Oh, it's a little different. How much would you need to deposit each month to do this? Assume a constant APR of 6%. So they had an example like this in the notes. Being stinking rich is what this example is. If we want to, if we want to realize 100,000 per year, where is this 100,000 coming from? If we're like generating this every year,
Your principal.
Yeah, your principal.
it's coming. This.
Okay, so it
So
says here,
you want your principal to be in the account, and the process to this is to have your principal untouched. So this is not something you would want to pull away from your principal. So if it's not coming from your principal, what does it have to come from?
Oh, interest.
It's coming from interest. So we want 100,000 in interest. We know our account earns what, 6%? So what they're saying is like 6% of something is going to give me that 100,000 each year. Is that making sense? Hopefully, if I spell interest right, it might make a little more sense. So if we're getting 100,000 in interest, basically we have this is the problem where you just have a shit ton of money, right? And you're drawing 100,000 off of your interest each year. So you're drawing 100,000 just off of interest. So I put a question mark. I guess we could make it a little more mathy, a little more algebra-like, and put an X there. But if we want to find out how stinking rich we need to be to just draw 100,000 and live off of money, we're going to do 100,000, 1, 2, 3, divided by what, 0.06. So 0.06 times this number will give us 100,000. So if we want to figure out the other way around, I believe we have to take 100,000 and divide it by 0.06, which gives me this ugly big number, 67. Okay. So how much money do I need in my account? What is that? 1,666,666 and something like 67 cents. So this is my goal. If this is my goal, that's like saying this is my, if I'm making a savings plan and this is my goal, what variable is that?
Accumulated payment
That's the accumulated or the A, right? Maybe I should say accumulated.
or amount.
Accumulated amount. That's my goal. So this is my accumulated amount that I want to have. So this, I don't know, we're kind of thinking about like this separately, right? We got to think a bit just to figure out what our accumulated amount is. They're making us do a little bit of thinking in this part of the problem. After we get this accumulated amount, now we're kind of thinking about it separately. Like, how much do I need to put aside to build this up? So this first question was like, how much do I need to get 100,000 in just in interest off of this guy? So each year you're going to earn 100,000 in interest, and this is how much you're going to that is going to remain in your account. You just like you take the interest off the top of this thing, and this thing just keeps earning 100,000 interest each year. Is what this scenario is that's happening. Are there questions about that? Like how this part is set up? Why we're doing this sort of thing? We're earning this in interest off of it. This should be the interest amount, right? This is the amount that we need to earn that interest. So after that said, this is our accumulated amount. We want to know how much our payment will be. So our payment is equal to accumulated amount times some crazy fraction. What was it? APR. Let's see if I remember it. Over N, 1 plus that thing. NY minus 1. A few years in, and I think I finally might have these things in my brain. I don't know if that's a good thing or a bad thing, but they might be cemented in there by now. So there we go. I think that's the correct one. Let me double check. APR over N, 1 plus APR over N to the NY minus 1. That's it. And we're multiplying this by that. So my accumulated amount, that's the thing that's out in front. That's the big nasty thing we just figured out. It's this crazy big number times some crazy fraction. My APR. So my APR is still, it's still the same APR that's on the account that they were talking about. It's still that 6%. My N, I believe we're still making monthly payments in this one. And so this looks like 1 plus 0.06 over 12 to the N times Y is 12 times. How long did they give us to save this thing? What did they say?
30 years.
30 years, I think.
Yeah, you're 30 years old and you want to retire at 60. So they say it kind of weird, but they mean you're saving for 30 years. And then we have to subtract 1, put some parentheses around these guys. So you should at least have this step when you're solving these things, right? You need to show at least a little bit of work, at least some work at the bare minimum. Like you should have that thing, right? You should have your formula. You should have it set up. This is kind of what I'm going to be grading, right? Do they have this thing set up correctly? This is going to be a big part of the grade. And like I said, you could probably skip a step or two from what I'm doing, but I wouldn't skip too many if I'm being honest. If we divide 0.06 over 12, that gives me 0.005. If I do 0.005 and I add 1 to it, I get 1.005. What's the exponent on that thing now?
12, 30. Oops, clear. 12.
360.
360, and then I subtract 1. Okay, so I'm going to do a few steps, probably get it a little bit quicker, probably a little bit quicker each time. So I get this crazy number. I got to multiply it by this fraction that looks like, if I raise 1.005 to the 360, that's going to give me 6.0225. And then I subtract 1, it's going to give me 1.0225. Or set it probably around it.
0.005. 1.005. 360.
And this, I'm getting an incredibly small number for this thing, 9.95 times 10 to the minus 4th. I guess I could go ahead and write it with like 3 zeros out in front, 9955, somewhere in that ballpark.
That's 12.
Which should hopefully make a little bit of sense. Like this is an extremely big number. We should probably be multiplying it by a relatively small number.
Professor, can you go up one page? I mean, one up right there. Let's
Okay.
see. Okay, there we go. Okay, so the bottom one. Okay, so
So we
it
raise
was 005 plus 1. Made it 1005. It goes on the bottom.
and raise it to the 360. It should
And
give
then it
you
goes 1005
to the 360 power.
to the 360 power.
It should give you 6.0226, right? Somewhere in that ballpark.
Yeah, 6.0225.
Yeah, and then we subtract 1 from that. Should give you the 5.002. 5.0226.
Okay, you round it off.
And then we divide these two numbers. We should be getting that crazy small number. And then the last number that you should get when you multiply these two things together should be 1659.18 if we round it up. Let's double check. Okay.
Professor, I have a question. So like on the tests and quizzes and stuff, so for like on this one, I was off by about 2 cents, but on one of the other problems that we first worked on, I was off by as much as 20 cents. If it's the same dollar amount, will that make as much of a difference as far as like getting the question right or wrong?
No, like as long as you, okay, so like the things that I'm really gonna look at is like you set this thing up correctly, right? You put in your numbers correctly. And like being honest, if you're like, if you're within a few dollars of this and you're like doing everything else correctly, I'm not trying to count off for rounding, right? But if it's like $1,000 and you're like $100 off or something, then you're a little far off. Like
Okay, got
if
it.
you're a couple hundred off on this, then I would have to start taking points off, right? But as long as you're within like, you know, a reasonable amount, like give or take $5 or $10, you know, something like that. It's like not a big deal on this one.
Okay, thank you.
Yeah, like I'm not trying to be like that strict. But with that said, like if you start rounding and you start rounding early and just start rounding to like the first decimal place or something, you're probably going to be really far off, right? And I'm going to have to count something off then. If you're a couple hundred off on something that's $1,000, then that's pretty bad. But a couple cents isn't bad. Like that's exactly like you're doing exactly what you should do. 2 cents, 20 cents on something that's $1,000. Yeah, that's nothing. Okay. Are there any questions about this one? This one is a little bit weird. The setup itself is a little bit weird, right? But then after that, I feel like it's just plug into the equation and solve it like the other two.
Yeah. So I got 1659.16.
That's it.
Okay.
Just 2 cents off. That's it.
Okay.
This is rounding. Compute the total and annual returns. So those things were a little bit weird. Do I have those formulas? I got those formulas right here. My total return is more straightforward, I should say, right? My total return is just my relative difference between my accumulated amount and my principal. This annual return was the thing that was a little weird, right? We do A over P, we raise it to a 1 over Y, and we subtract 1. So these are the formulas I'm pulling from. 5 years after buying 100 shares of XYZ stock for $60 per share, you sell them for $9,400. Yeah, they're making good money off of that one, huh? So how do we figure out their relative difference, or what do they say? Their total return is what we call this. Well, we take their difference and then we divide it by which one?
Well, wait. I assumed for this one that it was 9,400. You sell all of them. So
Oh, are they doing 100?
yeah, it's
Woo, missed that part.
otherwise
Okay.
that'd be just like a total windfall.
Are they saying?
So it's 100 shares at
$1,000?
$60 a share.
Okay, so yeah, okay. This is written really weird and annoying. Sorry. 5 years after buying, they're buying 100 shares for $60 per share. So if you're buying 100 shares for $60 per share, that means you spent $6,000 on your shares. That makes more sense, yes. And so this is like our starting amount, or this is like our principal balance that we're starting off with. And then they go to what? They're selling them all 100 shares for 94. I think that's what the problem's trying to say. They're saying it kind of weird. And then when they ask it in a minute, the number of years is going to be what? 5, I believe.
5.
So the first thing, we don't even care about the number of years for our total return. We're going what? 9,400 minus 6,000. And I want to divide this by,
6,000?
yeah, the 6,000. So this, we've done stuff similar to this before. This is my total return. So my total return is the same thing as saying the relative difference between these two things. Should be a little bit over 50%, 56.67%.
Yes.
So I'm probably just gonna jump right to that percentage. We've done enough of those.
Oh. 6, 7. Okay, so we moved 0.
Now I want to know annual return. So annual return is like saying if we just like compound this thing once per year, what would like my APR rate be? So it's like you're kind of generalizing it to like this thing that is being compounded once per year. You're like, what if this was a once per year compound situation? What would my annual return be? I think it's A over P to the 1 over Y minus 1. Is that what the formula is? Let me double check. A over P to the 1 divided by Y minus 1 is absolutely what it is. We have this formula. So things we got back solved from that compounding things once per year to get to this formula. We have this formula. Now we can use it. Accumulated amount was the what? The 94. The principal was the 6,000. 1 over Y looks like 1 divided by 5. And then I have to subtract 1. And this is going to give me like a decimal. I'm going to have to convert it to a percentage.
So why is it 1/5? Oh,
1 over Y, and we know the number of years is 5.
5. Yeah. Oh, I see. So we're gonna. It's a compound then, right?
Mm-hmm. This is a fraction in an exponent is what's happening up there.
Okay, so it is.
So if you look at this 94 over what 6,000, that's giving me some crazy thing like 1.567.
5, 6, 6.
Yeah.
5.
6 repeating, yeah, is what's happening. 1/5, there's a few ways you can do this, but like one way that might be beneficial is to convert it to a decimal. Sometimes it's easier to put a decimal in your exponent than it is to put a fraction in an exponent. Or what I would do is I would put parentheses around this. If you're putting it in your calculator, you definitely want to put parentheses because if not, your calculator is going to raise it to the first power and then it's going to divide the entire thing by 5 or something stupid. Like it's not going to do it in the right order usually. So you got to make sure your calculator's doing these things in the right order. So
when you put the parentheses in there, it comes out 0.2. But if you, if you don't put the parentheses in there, it comes out. Let me do this again.
It's going to raise this to that power, and then it's going to divide all of that by 5. It's not going to put the 5 up in the exponent. It's going to put it as a division or something weird. It's not going to do it in the right order. You don't put it in parentheses though.
Okay.
So you either have to put it in parentheses or convert it to a decimal. If you convert it to a decimal, I think it should work as well. If I just raise this to the 0.2 power, I'm getting something like 1.09394, somewhere around there, 0.9394. I probably want to grab at least 3 or 4 numbers out there. And then I got to subtract 1 from this thing. And so I'm subtracting the 1 off the front of that thing. And the last step is I got to convert this to a decimal or to a percentage. Sorry, said the wrong way. Got to convert the decimal to a percent.
Okay, I did something wrong here. I got 0.6. Okay, so wait a minute, hold on. Jesus.
This should be an exponent, so make sure you're putting it as an exponent. It's not multiplication, right? It's exponents.
Got it.
You got to raise it to a power. So yeah, I'm glad you're like I'm glad you're slowing us down on this stuff a bit. what you're doing is absolutely a common mistake. I know like you're being the only one vocal about it, but I guarantee you there's at least 10 other people in this class. They got the same problem and they're just afraid to raise their hand.
1, 0. Okay, so after the -1, I get 0.09399.
And we want to convert, there's your decimal, convert it to a percentage. So what we're saying is that it's like we have, this is almost 10%, right? We have something that's almost a 10% APR rate. So if I'm looking over here, I'm starting with 6,000. If I want to do 10% of 6,000, it's 600. So did this increase by about 600 over 5 years? I think it probably did. By about 3,000, right?
Mhm.
Yeah, that's about right. Okay. So each year over the 5 years, so each year, what this is saying is each year it increased by 9%.
Is that 9.399?
9.4, I think is.
Okay, so I got, okay, when I move it over, 1, 2, I get 9.399.
I don't know. It should be pretty close. 1.567 to the what? 0.2? 9399, yeah. So if you round it, it's 939. That's close enough. You're talking about like one 1/1000th of a percent or something there, right? That's not a big deal. Okay, so questions about this one, total annual returns?
Nope.
So in this one, both our total and our annual returns were positive, right? We get a total return is positive. We get an annual return. It was positive. What about 33? We're paying 3,500 per share, and then we sell them at a loss for 2,000. So which one is my principal here?
3,500.
The 3,500 my principal, and this is my accumulated amount then. If you want to go refer back to your formula, you can, but which one should I subtract from which one?
3,500 from 2,000.
Yeah, so I got to do 2,000, and I got to subtract 3,500, and then I got to divide that by
35, I guess.
the 35, exactly. I got to divide it by the number I started with. And then there's one thing, I got to like convert this to a percentage, but that's not a big deal. Let's just convert the decimal, right? So this thing, 2,000 minus 35 should be minus what, 1,500 over 3,500.
Minus 15.
What am I getting on this thing?
1,500. And then, so do you divide the minus 1,500 from the 3,500?
Mhm.
And do times 100?
Yep.
Percent? Is that how that works?
Yep. And so this is what, 42.85% or 857. But the important thing is that this is also what? And I didn't put it there yet.
In the negative.
It's got to be negative. So this thing should have a negative on it. It is a loss, and so your return should be a negative amount. We are taking 42% away from this thing. 42% of 3,500 is what, 15? It's dropping by that amount. So this one's pretty straightforward. The annual return is the crazy formula. It's A over P, 1 over Y, and then I got to subtract 1.
42.
So we talked about this. My accumulated amount on this one should be the 2,000. My P should be the 35. My 1 over Y, so I didn't look in this problem, but my Y here, my years, number of years. How many number of years did they say this was going?
3.
3. So we want to do 1/3. -1.
1/3.
And again, like you really want to put this thing in parentheses and do it kind of separately. I'm doing 2,000 over 35. Gives me like 0.5714. And I'm raising this to the 0.333 repeating. Probably just doing 0.333 is probably pretty close. Let's see. 0.5714. And we'll raise this to the 0.333. Subtract 1.
0.5714. That's what he got. And then did you?
216. Yeah, that'll get you close enough.
That's 0.33. Okay, yeah, that's I see it. Okay.
So if you want to round that, you could probably round it to 3 places. It will get you close enough. I just checked it. So it will give you close. It'll get you close enough for this class. 2,000 over 3,500. Okay. Got some enthusiastic neighbors apparently. Gotta raise that to the 1/3 and subtract 1. So the exact solution I'm getting without rounding is like 17%.
-1. So
It's about 17%, right?
oh, okay, I messed up. Okay, here I go. So it's 0.5.
And I should say -17. Sorry, dropping the negative sign off of there. It is important.
So 1/4.
So what this means is each year, this amount is going down by about 17%. You're losing about 17% per year.
And -1 equals. So this is a negative 0.1700.
Mhm.
What is that? What you got?
Yep. So negative 17% is where you're at there. Okay, so we did those 5. Okay, so now we want to talk a little bit about how to read a stock ticker. If I'm being honest, I would have no clue how to read a stock ticker if it wasn't for this class. Maybe a little bit, but like these things are not something that I would just know off the top of my head, right? Is what I'm trying to say. Like, if it seems a little weird or something, probably because I don't invest in too many stocks. But I think these things are pretty readable. Like if we want to know the price of the stock, it is this thing when we picked it. This is the change since the last day as a point, as a money amount. This is the change as a percentage. These are the number of stocks that we traded today. This is where it opened today. This was the high of the day. This was the low of the day. 52-week high and 52-week low. Those are pretty just self-descriptive, I feel like. We look at 52 weeks and see what the highest price was, right?
So is the end of the day 35.13?
The end of the day,
Or
like
is it-
yesterday?
Yeah, it
So,
says
yeah,
yes.
we'll have to do a little bit of work. That's one of the questions, so I'll answer that in a second. So what was the price per share at the end of the day yesterday? We'll answer that in just a second. I was just trying to get through this. So this
Okay.
market cap should be equal to the total volume times the price of the share. I believe is how they're getting the market cap, is the total number of like shares that got traded today. What is the price? What is the value of that? PE ratio is the price to earnings. That's what I meant to say. Price to earnings ratio. So we will do a few problems about that. It's a little weird. But they're taking this price, they're dividing it by earnings to get this number. So you have to do a little bit of back solving to solve for your earnings, but we will do a few examples on that in a second. Dividend is the latest quarter dividend, and then the dividend yield as a percentage. So we'll talk a little bit about that. So you're going to get 3.07% of however much the value of the stock you own, right? Was how much they're paying out on that thing. Shares outstanding tells you how many total shares of this company exist. So we are looking at an Intel Corporation stock. So the first thing says, what is the symbol for Intel stock? So what's my symbol here?
As much as anyone, I love them and trust them. Later on,
INTC.
Yeah, so INTC is the ticker symbol, right? INTC. What was the price per share at the end of the day yesterday? So today it is 35.48. It changed by going up 24 cents. So I think this is what Chris was asking.
Right. So do I minus that? Minus 24?
That's exactly what you do. You take the 24 cents away that it went up. So that is what, 35.24? Is that halfway there? Am I doing that right in my head? 35.24, right?
All right, 35.24.
Yep. Yeah, I don't know. I mean, I've looked at some. I don't know. Class is a really kind of taboo subject, right, to talk about. But like, there tends to be like a, what do I want to say, an inverse correlation between how people earn their money. Like if you labor, you tend not to make your money off of investments, and if you make your money off of investments, you tend not to be a laborer, sort of thing. Right? It tends to be the way that the world exists. I don't know what to tell you on that one. That is a fact of the world, right? So with that said, like I tend to make most of my money, all my money pretty much comes from labor, right? I'm not making money off of this because in order to make money off of investments, you have to have money to invest.
That's
like,
right.
There are different, don't get me wrong, there are different apps you can use, like Acorn and all that stuff, right? And I've looked and did a little research into them, but like, and they're good apps, right? And you can make money off of the maps. Like, don't get me wrong, you can make money, but you're not going to make real money, right? Like, I don't know how to say it, but it's not real money compared to like other people that actually have money and are making money. Sort of like that example where like, if you just have $1 million in an account, you can just draw interest off of that thing and live off of it, right? Like, that's not the same life I'm living. I don't know. It's a bit of a different life. But with that said, it is good to sort of know like how people are making their money, right? Even if you can't do it. Based on the current price, what is the total value of the shares that have been traded so far today?
Based on the current price.
All I'm saying is like, don't expect to get rich quick off of stocks, right? It's not a good, not a good strategy to go about.
Yeah, stocks is for people who've had money. Like you have a large amount of money and you want to make a residual off of it. But for you to try to get up into it, you have to invest for like maybe 5 or 10 years, you know, to get to the point where you want to be, where you ain't got to work no more. So yeah, I understand.
Yeah, so we want to go with this current price. Our current price is the 35.48. That's the last that they're talking about, right? So what is the total value of the shares that have been traded so far today? So we're going off with 35.48. This is the price per share, and we want to multiply it by all the shares that have been traded so far today, right? Which is which number? I believe
the 10,368,000. That's the volume, right?
That's the volume. Those are the shares that have been traded today. So if we do these two numbers, let me pull up that. Okay, let me make sure. 35.48, 10, 368, 1, 2, 3. What are they saying? Make sure we get the same thing. They're saying 368 million. Okay, that's it. So the book is even less specific than I am, if I'm being honest. They're going 367, 8, 6. They said 368 million in the back of the book. If you want a little something more exact, it's 367, 856, 640, right?
Yep. That's what I got.
So this is what part C, I believe, was That one. What percentage of all Intel shares have been traded so far today? So we have traded what, 10 million out of how many total?
Said okay. Had been traded.
It would be 4709.
Yeah, be that 4709. So there's a few ways you can do this. If you wanted to do what, 10 million out of what, 4709, that might be one way. If you wanted to write all your zeros in there, I guess that's another way. Either way, you should get pretty close to the same solution. 4709, and then I write 1, 2, 3, 1, 2, 3.
Wait a minute. So that's 4,709,000.
This is 4,709 million is what this is saying.
4,000.
There are, so this is in millions. So since this is in millions, what we really have to do if we want to get it out of millions is we have to put a million on there, right? We have to put 6 zeros.
But wouldn't that make that a billion?
This is 4,709 million.
Right.
That's absolutely right.
Okay.
And so we're doing 10 out of 4709, somewhere in that ballpark. If I don't do any rounding, I'm getting 0.0022, somewhere around there. And this is a decimal. They want to know what percent. Not a high percentage, so don't let that confuse you too much, hopefully. It's like a fraction of a percentage, right? 0.22%.
Okay, I got 20. Wait, hold on. Jesus.
10 out of 4709. 0.00. You might get 21%, right? If you do a little bit of rounding, but it should be pretty close.
2.2, right? So then you move it over.
And so it's D. What about E? E says suppose you're doing 100 shares of Intel stock. Based on the current price and dividend yield, what total dividend should you expect to receive this year? So if we earn 100 shares, and they're going off the current price, which is what, 35.48. How much money do we have invested in this thing? So hopefully this doesn't spend, you don't spend too much time on this, but if we have 100 shares and they're 35.48 per share, we should have a total of what, $35.48 invested. And they want to know about the dividend on this thing. So based on the current price, we found how much we have invested in here. We know the dividend is 3.07%. So if you know this is how much you have invested, how would you find your dividend? Maybe it's a little too straightforward of a question. I'm not sure, but like,
Multiply it by 0.307.
yeah, we're just doing 3% of this thing right here. So 0.03007 is what I'm doing here. I'm multiplying these two things. I'm finding 3% of how much money I have invested. And if I do that 35.48, I should get something like what, 108.92. Oh, the other thing,
divided by 3548.
I'm sorry, what was that?
0.3707 divided by 3548.
This is multiplying. So I'm multiplying these two numbers. I'm finding 3% of that. So the other thing I was gonna say is, like, I guess it seems kind of obvious, but like with investors are the people that make the real money, right? Laborers don't make real money in this world. At least like that's the sort of system that's set up. You're looking tired of me ranting about that probably, huh? E is 108.92 is how much you're going to make off the dividend yield.
108.
F, they say, what were the earnings per share for Intel? We know the price to earning ratio. So they give us this number in a really weird sort of way. We know the price to earning is 15.4. That's coming from the table. The last price that we're pulling off of this thing is 35.48. So we know when our price divided by our earnings is going to be 15.4. There are absolutely a few ways you can do this. You could put this over 1 and do some cross multiplying. You could do a host of ways. If you want to do this over 1 and do cross multiplying, we get 15.4 times E gives us what, 35.48. If you want to do it this way, this is a good way to do it. And then we divide by 15.4, solve for E. With that said, there is like a bit of like a shortcut. If you see something like this, it's a really cheap shortcut, but you can like kind of just flip these two. And you might notice this is what you end up with doing it the other way. And this is like these two things multiply to this, right? It doesn't matter what order I multiply things in, right? This is another way to look at this. These are the two multiples that multiply to that, or the two factors that multiply to that. If I divide by one factor, I get the other factor. And if I divide by this factor, I get the other factor. So there's a few ways to look at it. There's a few ways to set this one up. So make sure you find a way that works for you is what I'm trying to say, I guess. But my earnings that I'm getting here should be around what, 2.30 if I round it. So what it sounds like is that I'm earning, or that they are earning $2.30 for every share that they have. So that is their earnings per share.
Because this came out as a decimal, you change the value by moving the point back over 2, because I got 230.3896.
It should come out, no, it should be 2.3. If we divide those two numbers, it should be 2.3.
Oh, I'm bad. Okay, I forgot the point. 0.48.
So what were the earnings per share for Intel? They were $2.30.
That's right. 2 point. Okay, you're right.
And then the last one they want to ask is, how much total profit did they earn in the past year? So if they are earning $2.30 per shares, and they got that many shares, how much are they earning? So this is the one where we take the earnings per share and we multiply it by the total number of shares that they have to figure out how much they earned. And if we do that, we get 4709, 1, 2, 3, 1, 2, 3. What am I getting? 1.083 times 10 to the 10th.
Yeah.
0.083 times 10 to the 10th or something crazy like that. So I would really like to see this thing expanded out. So we got to go 3, 6, 9, 10 spaces. 6, 9, 10. Every 3. What is that? 10 million? 10 billion, I mean, is what that is, I believe. 830 million.
700.
Yeah, they said the book said 10.85 billion. So there we go. Close enough. I don't know where they're getting 10.85. That's a little rounding up.
Yeah.
But it's around 10 billion, right? 10 billion, 10.8 billion. What we do is we take the earnings per share and we multiply it by the total number of shares that Intel owns.
1.83.
So I think this
That
problem
means
is pretty
time.
similar to the one that I did in the notes. I'm not trying to pick off tricky stuff from these tables or ask you any sort of tricky questions about these stock tickers, right? So with that said, like if you know how to do this stuff, I think for the most part you will be okay for the test. Like if you know the ticker symbol, if you know how to find the previous price, if you can find the earnings, and if you can find the total profit, right? I think most of the other stuff is pretty straightforward. Like what percentage is this of that, right? Something like that. That's not too difficult.
Alright.
Suppose you own 100 shares. What is your yield? So you do have to know how to find dividend yield. But most of the stuff is I feel like I don't want to say it's straightforward, but maybe that's being a little presumptuous, right? I don't think it's like anything tricky with the table, right? It's like, or anything tricky with the specific knowledge to stocks or anything crazy. So 41 and 43 are the next two that we're doing, I believe. I think I'm doing extra ones. I think I'm gonna skip through them. So 41, 42, 43 is the next one. We don't have to do those. Let's not do those. I was getting optimistic, but we were learning. I think that was much time. IBM closed at 151.98 per share. Its price to earnings ratio was 12.49. And they want to know how much earnings per share. In part A, it's earnings per share. So I did one example, but I know if this is my price per earnings and that this is my price, what am I doing with these two numbers?
Divide, I guess.
That's exactly what I do. I want 151.98 and I'm dividing it by 12.49 to find my earnings. So part A, I think I'm getting 12.168, somewhere in that ballpark. I should probably round it up to 12.17, right? And they are talking about money. So part A says 12.17. And then they say, does this stock seem overpriced, underpriced, or priced about right, given historically that our P to E ratios range from 12 to 14?
You need life insurance. The chances are SelectQuote can help you get for less than $1 a day.
SelectQuote found Jacob 40.
So part B, what are we saying?
Priced about right.
It seems priced about right, yeah. Okay, I was double checking. That's what the book says. If it's from 12 to 14 and we're hitting 12.17, then we are in that range, right? So that should be priced about right.
We found Gary 35, a $1 million policy for only $22.
All right, 55, we got this little mutual fund ticker. It's very much the same way as a stock. This is our price. This is our change from the previous day, I believe 1 day net change, 1 day return in a percentage now. So this is in a money amount, this is in a percentage. And then they give you year-to-date returns. So these are like we're compounding them. We use like the compound interest formula to find these things, right? Typically, we either use 1 year, 5 year, 10 year. But these are annualized returns. So these are sort of like our APR rates. So suppose we invest 5,000 in this fund today, how many shares will you buy? So how do we figure that one out? So we got $5,000. We're dividing this $5,000 into these shares. So what should I divide this 5,000 into?
10.99.
That 10.99 will tell me how many I can buy. So I do 5,000 and I divide it by 10.99. What am I getting? 454.95. Okay, so
45495.
do they really do that? I don't know if that's possible. Is that? They do fractional shares in the book. I think you can buy.
So you round it off? Do you round this off?
Yeah, they rounded it to 9.6.
Okay.
I didn't think they sold fractional shares, but I could be wrong. It might also depend upon who's doing it.
No, they do fractional shares.
Do they?
Yeah, they have something like that in some of them, like Ally or something. What's the name of that? Jeez, I can't even think of it right now. Robinhood or something like that. They do fractional shares.
I know there's no, not Acorn, is it?
No, it's called Robin something. Robinhood or Robin. Hold on.
Yeah.
Oh,
See, there are a few different programs, and I was like looking at them, and I started to do a little research. There's some that you can
Yeah,
actually.
that's one of them.
There's some that they actually let you pick the company on, and there's some that they
Yeah.
don't let you pick the company on.
Right.
So that's definitely a consideration if you're like thinking about buying stocks. Okay, so suppose you invested 5,000 in this fund 5 years ago. How much would you need to how much would your investment be worth now? So this is like I'm saying, we want to do principal 1 plus APR. Forgetting my P in there. The P is silent. No, it's still there. Okay, to the Y. So this is a sort of formula I want to use when I'm figuring out annualized returns. And so if I'm investing, what, 5,000 as my principal, I'm doing 1 plus my APR. So my APR for, what are they telling me, 5 years?
Yeah, 5 years.
Is
It's
1.25%. 0.0, where am I going? 125, right?
Mhm.
Let me make sure I convert that right. Okay, so make sure you convert these right. I was trying to do it in my head too quick. And it's just like 0.0125 is what I want to do. And I want to raise this to the Y, which is to the 5th on this one. We're going for 5 years. So we've done a few of these examples, 1.0125, and I raise this to the 5th, and I multiply that by 5,000. Are you getting, I think I heard something, maybe I'm hearing something in the background. 530.20 and 41 cents, I believe, is what you should get out of this thing. So we want to add these and then do the exponents and then do the multiplication. So there's 3 things I'm doing there. Let me double check, make sure. This is part B, 53, 20, 41. That's it. Are there any questions about this sort of setup, how they're doing this? They do their annualized returns just like you're doing a compound interest compounded once per year, right? It's that same formula we were using in the previous chapter. See, they want to know for 10 years now. So what is 10 year? That thing all your professors try to earn, something like that. So how much would your investment be worth now? So this is the same thing. I want to do 5,000. I want to do 1 plus. My APR for 10 years is now going to be a little different. 0.0245, and I want to raise this to the 10th power. So already, like, I hope you realize you should be getting what, more money on this one, right? You're doing it for longer, and you got a larger APR amount. So I'm doing this right quick, but 6.3, 6.9, 27. So that's the setup. That should be what you get. That's what the book's getting. So I think we're good. Questions about these two or how these two are set up or how to find that amount given an annualized return? Okay. If we know the price of a share and we got $5,000, we can divide those two. We can figure out how many shares we're going to buy. We can do annualized returns. Those are things you should be able to do. And the final 2 problems, 69 and 73. Get started early. Mitch and Bill are both age 75. When Mitch was 25 years old, he began depositing $1,000 per year in a savings account. He made a deposit for the first 10 years, at which point he was forced to stop making deposits. However, he left his money in the account where it continued to earn interest for the next 40 years. Bill didn't start saving until he was 45, but for the next 30 years, he made an annual deposit of $1,000. Assume that both accounts earned an average annual return of 5%, compounded once a year. And so the second I see that compounded once a year, there really should be like one sort of formula in my mind, hopefully. To the y. Okay, I gotta like think about what your variables are that they give you in your book. In other books, they'll use T for time, and they'll use R for your APR or your rate. A and P are usually almost all the same. You almost always use A and P, accumulated amount versus principal. So how much money did Mitch have in his account at age 75? So if we're looking at Mitch, Mitch started when he was 25. He began depositing $1,000 into a savings account for 10 years. This
So that's 10,000.
it sounds like he's making regular payments.
So would that be 10,000 if he did it for 10 years? Or if he did it for 25 years? I don't know.
It sounds like he's doing a savings plan and then he just leaves it in there. Okay, so it sounds like we're gonna have to do a savings plan for 10 years. And then after that 10 years, whatever amount we start with, after that 10 years, we're gonna have to put it into like a basic compounded interest sort of thing. I think that might be the easiest way to get at how much Mitch is making. So for the first 10 years, God, okay, which one? Correctly and don't flip it, right? Okay, so payment times 1 plus. If I'm being honest, this is not like, I don't feel like they're the clearest in how they're setting this up. We will go through it. Not my favorite, or, you know, it's not, well, maybe I shouldn't say it's not my favorite, but probably not the best test question, but it will make us think a little bit for homework, right? So we're making payments. It sounds like we're making $1,000 payments. My 1 plus my APR here is going to be 5%, so 0.05. My N is just 1. We're doing things once per year. I do 1 times the number of years. I subtract 1. I do my APR over N, which is just 1. So this is the amount that happens if I deposit $1,000 for 10 years in a 5% account being compounded once per year. Woo. So 0.05, divide that by 1 is still 0.05. I got to add 1 to that. I got to raise that to the 10th power. I got to subtract 1 and then divide that by 0.05 and multiply that by 1,000. So I'm going to skip a few steps here. I'm probably just going to jump to it. But this is 1.05 to the 10th. I got to subtract 1, divide by 0.05, and multiply by 8,000. I'm getting 12,577.89. And this accounts for Mitch's like first 10 years of making regular payments. Deposits. He's 25. He's going to make deposits for 10 years, at which point he stopped. Probably left his money in the account for 40 more years. So he's got this money in his account, and now he's doing the Rip Van Winkle thing where he just falls asleep for 40 years on this amount. So we have to use this one for the savings account where he's making regular payments. We have to use this one this is my principal times 1 plus my APR, which is 0.05, to the 40 years. So he fell asleep on this amount for 40 years. God, I hope this is what they're doing. It's not the nicest written problem. This is 69. What are they doing? Okay. Whew. That is exactly what they're doing. It's not the prettiest thing, right? But it's like he goes from doing a savings account to just doing an account with a compounded interest. So if you do this amount, it should give you 88,548. And I think I'm getting like 20 cents on this. So this is Mitch. So he starts off 10 years and he starts off doing this account 10 years like it's a savings account, right? Then after the 10 years, he stops doing it like a savings account and does it like the Rip Van Winkle account, right? And he does that for 40 years. Any questions about like the setup or like how Mitch is doing things here? It's a little wonky. But that is the way the question's reading, right? He's like doing a savings account for 10 years. That's how much money he'll have. He quits doing the payments. That's how we have to figure it out. The other guy is, oh man, did y'all ever play the name game? I always remember Mitch and Chuck being some of the fun ones. So anyway, how much money does Bill have in his account at 75? Did I do that? 40 and 10, 50 plus 25. Okay, yeah. So how is Bill going to do this? He made a deposit. No, it's Mitch. Bill didn't start saving until he was 45 years old, but for the next, okay, going from 45 to what, 75. He didn't start saving until he's 45 years old. The next 30 years, he made annual deposits of 1,000. So this, he's not doing any kind of crazy Rip Van Winkle stuff. He's just putting money in there regularly like a savings account. So this should look like this formula. We're using this formula again to figure out Chuck or Bill. Sorry. I got Mitch and Chuck in my head now in the name game. A equals payment. Okay, so the payment that Bill is making, he's making $1,000 payment. I believe he's doing also 5% interest for 1 year, or for one compound per year, sorry. And he's doing this for 1 times how many years? It said 30, was it 30? 30 years, that's it. Minus 1.05, I guess we could divide by 1, but we don't really have to. So they want us to compare this. They want us to compare what? Doing this for 10 years and then sitting around for 40 years versus doing this for basically 30 years, right? So which one do you think might come out longer? It seems like this one might come out to a larger amount, right? We're doing 40 years here and we're doing 10 years here versus just doing 30 years. We're talking about 30 years versus 50 years here. But if we do this, I think this one might actually come out more. If we do 1.05, it raises to 30, we subtract 1. We divide that by 0.05, and then we multiply that by 1,000. The amount I should be getting on this thing is 66,438. And I'm going to do 85 cents to round up. So how does that compare to Mitch? So Mitch had what, 88,000? This guy has what, 66,000? And he did things 20 years less, right? Okay, so then what is the last question? They say compare the amounts money Mitch and Bill deposited in their account. Just did that. Write a paragraph summarizing your conclusions about this parable. What are they saying? Oh, we didn't look at the amount that they deposited. We look at the amount that they realized, right? I can't spell Mitch anymore. MITCH is Mitch. If Mitch deposits $1,000 for 30 years, how much money has he deposited? Or not for 30, for 10 years. Is that what Mitch was? 10 years. So if he's doing $1,000 for 10 years, how much money does he deposit?
10,000.
Yeah, we're doing 1,000, right? By 10 years. He's going to end up depositing $10,000 versus what? Bill? He's doing 1,000 for 30 years. So I believe he's depositing what? 30,000? I wrote it and you can't see it. So that might also make a difference in why what Mitch is earning what 88 versus Bill is earning 66. So it definitely seems like Mitch is getting the better deal out of this, right? But he also waited 50 years and Bill waited what 30 years. So they're trying to get a parable here, and I think the parable or what they're trying to get at is start saving as early as you can, right? The longer you save, the better it is. You're not going to make up for it just by depositing sort of more money. It's one of those sorts of things. The sooner you plan, the better off you kind of are. And like I said, you're not going to you're not going to bank it overnight probably doing this stuff. It is 2:35. If you got to go, we got one more example to go over. I will go over it. But if you got to go, I guess you can go ahead and bounce out if you really got to. You're not going to make a fortune overnight, right? But if you put a little bit aside each day, put a little bit aside, it builds up over time. Little amounts can build up. And they can save you. I know you're all just like waiting on the save money for a rainy day fund, right? You're just waiting on that lecture. It's not like there's anything happening in the world out there that might contribute to that. But with that said, the sooner the better, right? Is I think what they're trying to get at with that problem. A lot of things can change in a year. So who knows? Choose one of the 30 companies in the DGIA. Okay. So DGIA is the Dow Jones Industrial Average. Carry out research on that company as if you were a prospective investor. You should consider the following questions. How has the company performed over the last year, 5 years, 10 years? I think this sounds like a really good activity to leave y'all with. We're right at the end of the class anyway. Overall, do you think the company stock is a good investment? Why or why not? So go invest something. What is the DGIA? What are they talking about? Do y'all know?
Dow Jones and Industrial Average.
That's exactly what it is. They're talking about the Dow Jones. And I talked about it in the notes, man. I blanked out earlier when they were doing CPI or something. I was like, I think the Times in this one. It's the Dow Jones that is picked by the newspaper, right? Or whatever. Was it the New York? No, it's not New Yorker.
Wall Street.
Wall Street, that's it. Yep. So I found that a little bit interesting.
This is a depressing chapter.